Hi, this is Andrew. Welcome to episode 6 of the 345 Tech Talks podcast. In this episode, we are talking about the 10 principles for DevOps. We did have some bandwidth issues and a loss of internet connection during the podcast, so we had to re-record another time. So you will see myself and Paul magically change outfits. So if this happens, don't worry. We'll be, the content is exactly the same. Sit back and enjoy episode 6, our 10 principles for DevOps. 3, 2, 1, and we are live. Hello, everyone. Welcome to episode 6 of 345 Tech Talks. This was originally going to be episode 5, but the last one was so long we split it into 2. So our 7 outcomes for success is part 1 and part 2 formed episodes 4 and 5. So now we are on to episode 6, and this is really exciting stuff. Today's episode is our 10 principles for DevOps. So just as a reminder for everyone, this is the stuff we're building for Glue. And so a lot of which is our current venture, it is TripAdvisor for cryptocurrencies, the most trusted place where you can find out about cryptocurrencies, launching Q2 this year. Really exciting stuff. I have with me Paul Brown, who is Chief Engineer, CTO of Glue. I'm Andrew. I am CEO of Glue, and we are both co-owners of 345. And so there's a great sort of interplay between the things we are doing in Glue and applying that for our clients with 345 and things we learn from clients with 345 that we can then feed through into Glue. So just amazing technology stuff. So to kick this off, so DevOps. Actually, one of the things I was going to say, thanks to everyone for continuing to bear with us for the podcast. Literally hundreds of views on the podcast now, or views and listens, because actually the audio only version is doing better than the YouTube video one. So thanks to everyone listening. I'll make sure that I don't require everything to be on the screen, because it's since the audio one is doing better, for all you people out there listening in your cars and that sort of stuff, I'll make sure that I verbalize everything. DevOps, it's a big thing. It's a big subject. It's a hot subject, and I was searching for a really good analogy, and obviously the go-to analogy is DevOps is like sex, and then I fished around for that and riffed on a bit, and then realized that DevOps isn't like sex at all, and I thought DevOps is like gardening, because it takes ages to get it all set up how you want it. You then need to keep tending it constantly. Everyone that waltzes in thinks it's wonderful, but they've got no idea how much effort it took. And that's my DevOps analogy for today.
And you want repeatable quality with your carrots. That's year on year. So
absolutely,
it's probably a good analogy. Yeah.
Yeah. So there you go. If everyone out there, if you want to, if you want more analogies like this, sign up to Analogies R Us. Use the code TechTalks10, and for just $10 a month, we'll have a fresh analogy every day, winging its way to your inbox, like a trusted homing pigeon. So DevOps, it's a big subject, and one of the things that we talk about the 7 outcomes. We talked about it a lot of the last episode, and we look at so the 7 outcomes are rapid delivery, quality and bug free, available and scalable, secure, functional and lovable, costs are optimized, and we're standards compliant. Now with DevOps, we get at least 4 out of the 7, and we can argue about some of the other ones, but certainly rapid delivery. I think most people that do agile and rapid delivery realize that you can't really do that without DevOps. Quality and bug free. If you haven't got repeatable processes, you cannot have quality. You cannot have quality without repeatability. Repeatability is a prerequisite for quality. Available and scalable. Well, I mean, where does infrastructure and where does DevOps start and finish? So we could argue about that one. Secure, certainly, if you have automated processes, you can lock them down, and they are more secure than if you have people manually going fiddling with stuff. DevOps doesn't necessarily affect the functional side of things, but certainly costs optimized. We know we can make a big impact on costs by putting our DevOps in. and standards compliant. I think certainly some security standards and some, you know, some things like PCI DSS will be made easier through DevOps because you can show that you have repeatable and secure processes. So DevOps touches a lot of the outcomes, and actually, we talked about our seven strata model or seven outcomes, six strata. So we talked about our six strata model, which is like the determine, build, verify, release, run, and team, and all the things that we put in that. And again, if we look at that as where does DevOps affect that model? It's almost everywhere. So for us, like, people blithely say, I want a bit of DevOps. Actually, it's a massive thing, and to do it properly, it almost gets into every single corner of our of the delivery of technology and running a technology business.
It's almost cultural. There has to be a culture around the business in wanting to automate, in wanting to have repeatable processes in order to drive quality. So it is definitely a cultural thing.
Yeah.
DevOps isn't something that sits on the side and it's the little team over in the corner that, those guys are doing some automation, but we carry on writing code. But those guys, they just do their own thing. It's much more fundamental than that. It is part of. It's a fundamental part of the team and a part of the culture of the way that you develop software.
Yeah, and it's and that's why, I mean, almost every business we go and work with says, I want DevOps. And the ones that find it really hard find it hard because of people and cultural change, not because technology. So that's really where really reinforces what you say there, is that it changes how people have to behave. It changes the responsibilities people have. And as much as anything, there's a whole load of things that people can't do. And a lot of those things they can't do are shortcuts.
Yeah. Yeah, that's true. Yeah, it sort of stops that, doesn't it?
It doesn't, and
it aims to stop that, right? So
yeah, it aims to stop that. And when you stop people making shortcuts, but why do people take shortcuts with things? It's to do short-term activity to alleviate an immediate pain, to alleviate an immediate problem. But it's like taking painkillers when your leg's falling off. It's like it doesn't it doesn't solve the underlying problem. You're just kind of able to ignore it that bit longer.
Yeah.
And so that's why it's we all know people that would rather take painkillers than go to the doctors.
True. That is true. Another great analogy.
A lot of people think, a lot of people have heard the term CI/CD, and I think one of the things we're going to really go with this is that it's much wider than that, isn't it?
It is, yeah. I think it's sort of it's one of those things where DevOps has just become that sort of byword for we must do continuous integration and continuous delivery.
Yeah.
And
there's not a lot of ops in that, really, is there?
No, well, I mean, to the delivery part, I guess.
Yeah.
But it's it's sort of we need to do DevOps. Actually, what we need is an automated system to allow us to push application changes into a running environment. Yeah.
Yeah.
But as you say, it is a lot more than that. It's about embedding the operational requirements and the operations teams in at the start of the project, so that their voice is heard for what they need.
Yeah.
And their requirements are treated no differently to application requirements. Functional features that are needed to be developed in the application. Operational requirements are just as important.
Yeah.
Because at some point you've got to run the system and you've got to support it. So those, it shouldn't just be a case of, well, let's throw the application over the wall to the ops team and let them deal with the outcome of that. It's right at the start. What do we need to do to support the operational deployment and continuing support of this system?
And
And
it's
so that's why it's really important that
yeah.
DevOps is actually also about making sure that the operations teams are brought in right at the start of the process and are given an equal voice.
And not only that, it's also the fact that if we talk about there's no manual fiddling with stuff, and and everything's automated. What that means is that if we deploy some software and the configuration is wrong or the settings are wrong on our infrastructure or that sort of thing, those should be handled as bugs in the same way that application issues are handled, and so that we go back to the start, we fix that at the start, you go through another cycle, and then it's fixed. But this time we know it's fixed for good, because if you've got an operator who's gone in and ticked the tick box that was missing, you fixed it once, but then it's going to break again. And
Exactly.
whereas if you treat that as a bug, you go back to the start, and then you fix it for good.
Exactly, and that's the word repeatability.
Yeah.
Again, if you have to provision a new environment and you don't know anything about the tick box that somebody ticked on to solve that short-term pain, that short-term issue, then you're going to end up with a new environment with the exact same issue as you had before, except this time the guy that put the tick that ticked the box might not be around, because everybody's standing there scratching their heads, thinking,
Yeah.
why does this environment not work like the other one?
Yeah, and that's because and in that situation, you you can't guarantee your quality.
Exactly.
So yeah, we said sort of it's DevOps is more than CI/CD, but I think we have to at least say what CI is and what CD is, and then as we go through, we'll kind of I think all the other bits that go around that will flesh themselves out. So for the benefit of anyone that's been in anyone in the technology world that's been living in a cave since 1994, what is continuous integration?
So continuous integration is the continual it's the continual process of whenever you make an application change, that you are continually building, testing, and deploying that application change.
Yeah,
So you,
and this was kind of going back to kind of old days. But that when you had particularly different teams building different parts of a system, they'd all build their teams, and right at the end of the project, they'd all say, right, we've all built our bits, now get them to work together, and it would be a bit of a disaster time, and then you go through this kind of integrate and stabilize phase where all this stuff was where you had a few weeks of calamity whilst all these different teams crashed their bits of software together, and so continuous integration kind of came out of that, didn't it? It's like, no, instead of crashing it all together at the end, why don't we continuously get all that software integrated so we can flush out the problems early and not flush them out later, and I think that's
exactly. So every change you make should be able to be tested in the entirety of the application to ensure that your one change doesn't cause any regression, doesn't cause any issues. And so rather than I don't know, 100 developers making lots of changes, and then at the end of the week saying, right, okay, let's now build the system and then test it. You're doing that on a continual basis. You're doing that on every change, and every change is tested in isolation of the sort of the gold application, and so therefore by doing that you're driving up quality, because those changes don't need to be committed to the sort of the gold application until such time it's been proven that they're good changes.
Yeah, and the other thing is that I mean, it's one of those things that back to sort of shortcuts, that when you've got loads of developers building stuff on their own, they might feel like they're making progress really fast, without realizing that that when it comes to this whole thing of getting a whole load of different developers work, to integrate their stuff together, that so they might think I'm building it really fast, really fast, really fast, and then suddenly we've got 2 months of like going nowhere because we're just trying to integrate that. And so
Yeah.
for people that aren't used to continuous integration, it feels like it slows things down because you've got to pull everyone else's changes down, merge them into yours, and then push them back and then make sure it's all right. And that feels like it slows you down, but actually, in the long run, it speeds you up because you know then that once it's in and once you've continuously integrated everything, then you don't have to do all that going back. So
Yeah, exactly that. And I mean, applications have got bigger as well, and there's more aspects to an application in terms of application components, infrastructure components that support the application, and so on. And the bigger the application, the harder the job is to do it the old way. If you were
yeah,
building a little VB app, like we did many years ago, then you would compile your little VB app, you run it on your desktop, and it's like, well, I can see that that works or doesn't. But when you start to build distributed systems running in the cloud and so on, then it becomes ever so much harder to ensure that that application will work when you bring it all together.
yeah, absolutely. And then CD, and so so C. I think a lot of people kind of get a bit confused about the handover between CI and CD. Um, so where do what's CD, and then where do those things kind of hand over onto the other?
Well, I mean, it depends on who you talk to, really. I hear continuous delivery or continuous deployment, but um,
So I'd
it's
say delivery.
I'd say delivery. I tend to say delivery. I might lapse occasionally and say deployment,
Cause,
depending on the day.
yeah,
But
because I mean it's
generally speaking, I would say continuous delivery.
yeah, because a lot of this goes back to Agile Manifesto, doesn't it? Because really it's it's I can't remember the exact wording off the top of my head, but it's something like we provide value by continuously delivering value. We delight our customer by continuously delivering valuable software, and that's the and I think the wording that's where I believe the wording for continuous delivery comes from the Agile Manifesto. Um, but yeah, it's but but continuous delivery is so for me, correct me if I'm wrong. CI is yeah, this code is good, and then CD is we've got some good code that's changed. Now let's ship it.
Yeah, I mean that's a good distinction, really, to be honest. So your CI is my change good, and does it work in the in the context of the application? And now I need to deploy that change so that my customers can take advantage of that new
Yeah,
that bug fix,
that new value.
new value. And so that although you may actually do so as part of the CI process, you may actually be deploying the change in order to test it.
Yeah,
The CD part is actually I'm going to deploy that to an environment in which I can make that available to my customers. So typically a production environment.
yeah,
Although quite often, we would stage that change into a staging environment, and then because we may need to have maybe an approval process by which we then make a set of changes available in a production environment. But we
yeah,
would stage that change first. So I would see that as being part of the continuous delivery process to stage the change, and then at such an appropriate point in time to then deliver that change into a production environment.
yeah. Because going back to old bad waterfall days, devs would, dev teams or build teams or whatever would kind of make applications, and then at some point they'd say, the application's done, I'll throw it over the wall, and there you go. And often release teams were part of ops, and they would actually then take that through a path to live. And what we're talking, and that might include perf testing, and it might include integration testing, and it might include operational testing and failover testing and all that sort of stuff. But they would but there would be a path to live, and what we're doing with continuous delivery and with DevOps and automation is saying, okay, there is a path to live, but it's an automated process, and
It's an automated and generally speaking, um,
and it
uh,
happens often.
more rapid
Yeah,
process.
so
In terms of the cycle of deployment, tends to be a lot quicker than your more traditional application deployment,
yeah,
which depending on the business, could be once a month, could be once every 6 months, could be once a year. I mean, if you think about, we've talked about regulated businesses.
yeah.
There tends to be, a longer cycle between deploying new versions into a production environment than there typically would be in, say, I don't know, just a social media website.
But on this note though, there's a thing whereby, and in the real world, when people deploy infrequently, they they tend to have a mindset that deployments are risky, and so they deploy less frequently because it's more risky, which means that every time they deploy, there's more change that goes in, and so it's almost so. One of the other things that that's important about continuous delivery is, and this is kind of counter to those type of businesses, because I think, because a lot of those businesses are very risk averse, and it's like the irony is that the more often you deploy, the less risky your deployments are, because particularly once you've automated them and they happen often, what happens is that your application has very small changes, and so the risk of something going majorly wrong is much lower than infrequently delivering a huge amount of change, and then it's like, oh, that's risky, isn't it?
Yeah,
Who'd have thought that?
and typically a huge amount of change involves most aspects of probably an application, and so
Yeah,
therefore you have to upgrade the entire application
and
with
and and then things effectively become like monoliths, and then
exactly, and you typically end up in the scenario where an application upgrade is, we're going to take the system down
yeah,
for a period of time.
and regression cycles are really onerous because you've got to test everything every time, and
Exactly. So it's the more change you pack in on a release, the more likely you are going to have some sort of downtime in order to deploy those changes.
yeah. So I think we've done a good lot of setting the groundwork. We've only been going 20 minutes, so that's
Oh, that's not too bad.
that's not too bad. So we better start cracking on with our 10 principles and get through these. So okay, so 10 principles of DevOps. Principle number one: everything is automated. What can we say about this?
Well, I think this is the core principle, right? So I think everybody is trying to, anybody that's doing DevOps, I think, are aiming towards having all of their regular processes automated from a
Yep.
DevOps perspective. I mean, that's the sort of end goal, right? The vision of when you complete almost like complete DevOps, that all of your processes to support your code deployments into a production environment are all automated.
Well, that's it. The dream is that we add value by creating new solutions, not from going through not from winding the handle on the sausage machine to get those solutions into a production environment. Or
Exactly that. Winding the handle on the sausage machine. That's a good analogy. It is exactly that. So you don't really want to be doing the same old manual process every time. I mean, for one, it's not repeatable. So we've talked
and
about quality
yeah,
before.
you can't have quality without repeatability. Repeatability is a prerequisite for quality, but it doesn't guarantee quality.
Exactly. So you certainly don't want to be aiming to continue with manual processes. So you need to automate as much as possible. And
And it's boring as well.
well, it does. Yeah,
I mean, let's
exactly
let's
that.
face it. How many times, yeah, we all know infrastructure guys who used to just have to put the CD in and press next, next, next on the wizard, like, and that was their job. I mean, how soul destroying is that? So, um,
Well,
we're
yeah,
free, you know.
I used to do that many years ago. I used to put a tape on an IBM tape machine. I used to have to drive all the way to Basingstoke to put a bunch of tapes on a on an IBM tape machine. I mean, it was it was a few hours out from the office, but yeah, it's very very much a manual process. And while it got me out of the office, it was it was a waste of time, really.
So this is for all the kids watching. People really did use tapes.
Yes,
Obviously,
they were big round things. Yeah.
obviously that's before my time, mate. Uh,
Oh, clearly, yeah.
but I do remember floppies.
Oh, yeah. Yes, indeed. So, yeah, so it is boring, and when things get boring, you don't give 100% focus, and that's when errors creep in. And so, automation is absolutely key to get that repeatability, to get the quality up, and just get people doing things that are more valuable.
Yeah.
So some of the things that we obviously automate are things like a lot of the sort of quality checks that you would have on a bit of code that's changed. So you make a change to the code base. All of those those changes need to be in effect regression tested to make sure that it's good before you merge it into your master or gold branch. So we do a lot of static code analysis, obviously run tests, automated tests, and then the application's packaged up. So that's all automated as part of the sort of continuous integration process.
Yeah.
And then obviously the deployment of that application. So we deploy the application in containers. So deploying that application to the various environments is all automated, and also the infrastructure itself. So we also automate the provisioning of an environment and also any upgrades to an environment.
And funnily enough, I mean, we'll get onto this in the later ones, but actually automating infrastructure and that sort of thing is such a massively important thing, because we've seen we've worked with clients that are trying to do their testing cycles on software, and they go from one environment to the next, and they're all different. And then they've got individual machine, like if you're trying to load balance across a bunch of web servers, and they're all different, even in the same, even if you're in like your staging environment, and you've got a web farm with 10 web servers on it, and they're all different because someone's manually done it. I mean, it's just, how can you, that is often where you get the real kind of issues because of the infrastructure, not necessarily just the application.
Yeah, even if you rebuild, I mean, occasionally like your test systems and so on, that you've had to rebuild a test system, and you rebuild it, and you think you've done it the same way, and when you go to use it, it doesn't work, and you're like scratching your head trying to figure out, well, what's gone wrong here. I mean, obviously, these days we have the cloud. We have the ability to provision through sort of definitions and templates, which make it a lot easier.
Yeah.
But even so, you still, you still need that automation to make sure that you've got a pretty good chance of when
to go from a vanilla cloud server through to one that is configured for your application, whether that be a Kubernetes node or whether that be a web server or whatever. You still need to go through that automated process to get it from the point at which the cloud provider has provisioned it for you to the point at which you can actually use it.
And having the confidence that when you go through that process time and time and time again, that it's actually going to work every time. So you don't burn time trying to figure out issues that have crept in as a result of rebuilding it. So it's that's why it's principle number one.
Yeah.
Automation is the key. It's interesting. The whole if you've got everything 100% automated, then you're very lucky. Most people don't have everything 100% automated. There's always manual processes that maybe maybe they're so infrequent that the cost of actually implementing is maybe not worth investing in, or maybe they're just down the priority list. Maybe there are other things that need automating before. But the concept of having
there's a destination. It's a destination we're moving towards, and we're going to get as far towards that destination as we can. And even if you're not right there, the closer you get to it, the better position you're in.
Exactly. But there is a term for the manual processes. So Google coined a term called toil, which represents all of the manual processes that actually could benefit from being automated, because they're just toil on someone's part.
Or toilet. If they're a small bit of this, it's toilet.
Yeah, well, quite possibly. I'm not quite sure they've used that term, but yeah.
Well, Google, if you're listening, and you probably are, because this will be on YouTube, you can use that one for free. Have that one on me.
Yeah. It's a great word actually, toil, because it's all right. It really does represent.
Yeah, and it's because it's particularly the repetitive, non-value added.
Exactly. Yeah.
It's like if you're, people used to toil in the fields until we could mechanize it.
Yeah.
And it was just back-breaking, repetitive work. So it's a good thing that we don't have the toil. One thing, and I'm looking at my notes, or rather, I'm looking at your notes, Paul, and that is that we've got a little note about containers. And is there anything, as viewers and listeners of the podcast will know, we're really big on containers, and we're big on Kubernetes and running Docker containers. When we're talking about automation, is there any what does containerizing give us as a bit of extra value?
So the one thing that containers do give us is that it gives us that sort of consistent application environment. So once we build the container, that application environment that application runs inside the container is then consistent across different infrastructure environments. So if we're deploying that container from test to stage to production, it's the same container. Then there might be some configuration parameters that are different per environment, but in terms of the runtime environment and the way that the assets that are held in that container, like maybe dependent packages and so on, that at least stays consistent. So once you've tested it, then you've got a pretty good chance that that's actually gonna work in every environment, and then you only really need to care about the differences in each environment.
Yeah.
In terms of like the external resources that container or that application within that container might access.
So it's almost like a shortcut. It's just an extra bit of easiness that makes takes a lot of work out of what we're trying to achieve.
It does, yeah. I mean, if you think you think back to the days when you deployed applications directly onto machines, and if your machine needed to run multiple applications, then there was the whole balancing act of making sure that the installation of one application and its dependencies didn't affect other applications that were installed. So there was definitely
which it invariably did.
Which invariably it did, and service packs or
service packs, the particular version of MSXML you were using, or something like that. That was just like
I'd forgotten about that, but yes, exactly that.
it was always a nightmare.
And that can break applications. So containers have helped in terms of not just deployment, but in terms of quality. So the dependency hell that you might get from having multiple native applications deployed on one machine, then you break that dependency by having each container have its own its own application environment. So all the dependencies of an application are contained within that container, and then therefore do not affect any other application in another container that might be running on the same machine. So it's definitely improved the quality of running those applications through different environments.
Cool. So automation. So summing up, automation is like the one principle to rule them all. To Lord of the Rings Fi.
Coin a phrase, yeah.
To coin a phrase, and so absolutely. I think
I like that actually, because I'm a Tolkien fan. So the one principle to rule them all is automation.
Right. So we'll probably now just stretch the analogy too far, but we'll move on to the next principle, which obviously we're going on to the 7 dwarf principles now, or the 9 principles for mortal men, following that one. So I like that actually.
Yeah.
So principle number 2, we have Git is the source of truth, or substitute your repo of choice. But yeah, obviously we use Git. We've used Git for years and see no reason to change it. So for us, principle number 2 is Git is the source of truth. Where do we start on this one? It's
So I think this is actually an important principle, in that if you want to know about what's running in an environment, or what does, so you have an infrastructure environment and it's configured in a certain way, and all these various different settings are switched on, and applications are deployed in it, and so on. It's like, how do you know at any given time what that environment contains?
Yeah.
You should be able to find that information out by looking at your source code repository.
Yeah, and as a kind of a wider principle, there is a thing here where businesses that run well effectively know what their source of truth is, and businesses that struggle and suffer are the ones where someone says, how'd you do this? Where's that? And you have to say, well, Barry knows. Let's go. Where is he? Oh, I don't know. Maybe he's outside. And you have this whole thing of knowledge being in someone's head or being scattered, or no one knows where it is. And so as a general business thing, knowing your source of truth is an important thing in a software thing, or in a software systems technology thing. We make that a bit more specific, saying Git is source of truth, but it's a key principle.
It is. So all of the artifacts of everything to do with infrastructure and application are all held in a Git repository, or in multiple Git repositories, depending on obviously what the artifacts are that we're storing in there. So we also use Git as in effect a security boundary. So we would have, say, the different infrastructure environments are all held in different Git repositories. So mainly because they have different shapes. So the definitions of those infrastructure environments are held in Git repositories, but the different shapes are held across different repositories, which means that we can apply different security permissions to them.
Yeah.
For example, we can lock down anyone changing the production environment. compared to, say, I don't know, the development environment, which may be a bit more open in terms of who can change it. So that's another, and also we have certain repositories, application code that is quite sensitive. So anything to do with security.
Yeah.
Any repositories that are security focused, we can lock them down with different permissions. When it comes to doing the quality checks like code reviews, being able to merge to master, we can obviously change the permissions on that to say, only certain groups of people can review the code changes on this and approve.
And only certain people can merge.
Yes, exactly. So we also use Git as a security boundary. But the key thing out of all of this is that actually Git is a great audit trail.
Yeah.
Because it stores the history of changes and who made them, against all of those artifacts that you're storing in there. So it is the source of truth, not just for the actual artifacts themselves, the code files, the infrastructure templates, and so on, but also that history of who changed what, pull requests and so on. So it goes beyond just storing the latest copies of all your different artifacts. So it's a fairly concise principle.
And it's also, I mean, it ties in, it builds on principle one, because if you are automating everything, then automation ultimately means that you have some sort of script, and that script is versionable, etc. So it builds on that, because if you're automating, then your script should be in a repo and versioned and audited, and you can control who can change it and all that sort of thing. So it very much builds on principle one.
Exactly that, and that is a really good point, because we're not just talking about infrastructure and application, code in effect, but also the DevOps process itself.
Yeah.
Is series of scripts and so on that are also stored in a Git repository.
Yeah, because the DevOps process is a solution in its own right.
Exactly. So even our DevOps environment. So one of the things that we can do with the way that we've got our system set up in Glue, our DevOps system set up in Glue, is we could quite literally wipe everything out, and then we have a process through script files held in Git, and we can rebuild from the ground up.
Yeah, so as long as we've got the repos, we can bootstrap everything else.
Exactly that. So all the way from the DevOps environment and up, which I think is a really, really nice place to be. And as I say, not everybody's going to be in that position. We've been pretty lucky, because Glue is obviously a greenfield development, reasonably new. So we're taking advantage of the times we are in now with the cloud and a lot of these tools now that are making DevOps much more accessible, much easier. But it is a really nice position to be in, to be able to say we could have a complete wipeout, and then we can rebuild from the ground up, and everything's automated.
Yeah.
I mean, there might be some manual. When I say automated, there might be, somebody has to kick something off, but the actual process itself of building and then deploying and so on is all automated.
No, that's good stuff, and it does lead us into the the next principle, because principle number 2 being everything is in Git. Principle number 3 is that no sensitive data or values are stored in Git. So this is the everything's in Git, but don't get carried away.
Yeah.
There are limits, and the limit is that given the fact that different people have access to Git and or the repos, and given the fact that all that gets packaged and bundled, that anything that is sensitive, it shouldn't be in there, and there's more than one reason for that. So
Yeah,
I'll let you elaborate on that one while I have some coffee.
yeah, is yeah. So everything goes into a Git repository except obviously secret type data. So, and I think that's I would say that's pretty obvious. It's actually not necessarily as easy in practice as it sounds when you say it's a principle, because you've still got to have some way of provisioning, secrets, which could be anything ranging from a password to a security token, to an encryption key, to a certificate with a private key attached to it, and so on. Could even be, I don't know, more data like personal data, or personally identifiable information. All of those things shouldn't really be stored in a Git repository. I remember reading some time ago now, actually, or at least a couple 3 years ago, where somebody had accidentally committed their AWS access keys into a Git repository. And the first they knew about it was when they got I think they got an alert from AWS to say that they'd exceeded their
billing limit.
billing target, and I think what it was is that it turned out that somebody had obviously been scraping Git repositories looking for these types of.
And so they not only did they put this in a repo, but they put it in an open source repo,
No,
or a public repo or something like that.
I think there was an issue where it was supposed to have been a private repo, but it accidentally become public, and somebody had been scraping over the public repos looking for things like access keys, discovered it, and then was spinning up virtual machines like there's no tomorrow. I can't remember what they were using them for. I think it might have been like crypto mining or something like that.
Yeah.
But I laugh, but it's not a laughing matter. But it really was. I think it's quite a fraught time for the guy that ended up in that situation. But it's just the sort of, even if it's a private repo, there's
don't rely on that.
it's not a good it's not a good approach to take. I mean, secrets are secret for a reason, and even secrets, and certainly in more sensitive environments, secrets associated with more sensitive environments. You don't even want your own developers, your own people really necessarily to be exposed to those secrets.
Yeah. So and there are some things, and again, we deal with crypto and that sort of thing, and there are some there are some private keys that really you want to have them in an off-site safe, and for no one to, and for them to be in your secret store, and the rest of the time they're in an off-site safe if you need to recover them or something like that. And apart from that, no one should have them, because that as a security thing. I mean, quite literally, what you don't want is you don't want to be and this has happened to this has happened in the world of crypto, where people have been kidnapped and asked to hand over their keys. And if you've got them, then you're vulnerable. You're actually vulnerable to that. If you say, "Look, I haven't got the keys," which is the case with us. So if you kidnap us, we haven't got the keys. I just make that clear now. They're in a safe, and that safe requires multiple people to open it. And so, and if you're really serious about security, you can be in. There are measures like that you can take.
Let's hope it doesn't get to that point.
Yeah, don't kidnap me. I haven't got them. Paul's got them. Maybe I should have said that one.
Yeah, it's get slightly off topic. Let's get back to the principle. It's actually quite a good discipline, because as I say, it isn't particularly easy. Necessarily is as easy as sticking everything in a Git repository, and so it forces you to think about how you're going to deal with sensitive and sensitive data and secrets
Yeah.
and so on.
And who can access them
And there are
and all
other
that. Yeah.
places that they can be put. We use in Amazon, there are a number of different services that you can use. So the Secrets Manager, which is fairly new. There's the Key Management Service. There are hardware HSMs that can be used, and so on. Obviously, there's a provisioning piece to it. Somebody's got to provision the secret into it somehow in the first place. But once it's in there, then it should be protected from. No one should be able to see it in plain text, and then it should then be protected based on the permissions of the user, whether that's an interactive user or like a service account. It should be based on the permissions that's been applied to that account as to whether they can access it or not. But what it does do is it forces you to think about, how am I actually really going to manage these things? Because, part of managing secrets, you need to have like rotation policies. Yeah.
Yeah.
So it's good practice to have the ability to be able to continually refresh secrets. Particularly, I mean, obviously, if you have a secret that's been compromised, then you're going to have to refresh it anyway.
Yeah. So the
Having
fact,
that general process is good practice.
yeah. So the fact that if you have a rotation policy, that's forcing you to put in place a process for changing those secrets and reapplying them. And so if you haven't got that, if you never rotate them and you get compromised, then it's like then that is suddenly a really hard thing to do. Whereas if you have a rotation policy and a rotation process that's obviously automated, then you can actually just run that same process again, and then you've got your and then you've re-established your integrity of your secrets.
Exactly. So I think that's principle number 3.
Principle number 3 kind of
Wrapped up.
done.
Yeah.
Okay. Principle number 4: adopt an infrastructure as code approach.
Yes.
Yeah, we're spoiled now. With the world of cloud, or now that I mean, we've for quite a number of years now, we've been cloud first, and we've had a policy in both in 345 and in Glue that of no tin other than what's on people's desktop. And it's a fantastic position to be in, and we're fortunate that we can adopt this. But why wouldn't you do infrastructure as code? What are people doing, and what's the impact on that?
So, well, I mean, if we sort of explain what infrastructure as code is, it's basically where you manage your infrastructure environments through like code definition files or templates, as opposed to managing the environment with a sort of console, a console in a browser or whatever. So you're actually making changes directly to the environment through some sort of tool, interactive tool, as opposed to making changes to a template and then deploying them through an automated process. So in effect, it's much more controllable, and this all goes back to principle 2: get as a source of truth, because the way that you change your environment is to change templates and then deploy them. So and go through the same sort of CI/CD process as an application, as a bit of application code. So you can go through your quality processes. You can then deploy that change out to different environments, depending on obviously what that change is. And that's far more controllable and far more repeatable than somebody going directly into a UI application, whether that's a desktop app or through the browser, and switching settings on and off.
Yeah.
Because you've got no record of people, unless you've got some, unless the environment provides some sort of auditing, you've still got no record that somebody's done those changes, unless those changes have been reflected back into some sort of repository somewhere where it's your source of truth.
So, so,
So
so just on this, infrastructure as code, does that really then is that really then implying that you need to be virtualized?
um, pretty much, yeah, because you can't. I mean, obviously, you can't have a template file for a bit of hardware. So it does imply that your machines and your infrastructure is virtualized, because that's the only way that you can really, the template definition files only really work in that respect.
Yeah.
Um, so you either need to have an existing hardware environment in which you've then created virtualized machines and services on top, or you're using the cloud, which is from the perspective of the consumer of the cloud, everything's virtualized. Obviously, Amazon have, and Microsoft and Google and so on. They all have hardware,
Yeah,
and
they're worrying about that.
they're worrying about that. Yes, exactly. So all we care about is being able to provision services, provision machines, and so on, and we do that all through template files. So it does imply infrastructure as code. It does imply that you are looking at virtualization. But but again, it ties back in, as I say, it ties back in principle two, get the source of truth.
And
It's
principle
very
one,
repeatable.
yeah, principle one that we then deploy that in an automated fashion.
Exactly. And yeah, it almost seems reasonably obvious, but it's definitely one that's worth pointing out as a principle, because it's all too easy to go into the cloud console and switch a setting on, or change a setting. I don't know whether there's some sort of threshold, or let's just increase the threshold, as opposed to having the discipline of going back to the template file, making the modification there, going through the review process, going through the quality processes
Yeah,
before that's deployed out.
because again, if the next time you do a deployment, if you've done that tweak, you'll lose it,
You lose it. Exactly.
and you won't have captured you won't have permanently captured that goodness. And this is one of the things that we yeah, one of the things that software is really good at is marginal and incremental gains. That you make improvements, you fix a bug, you put in a feature, you do this, you do, and all the time you're making either your product or your service or your quality better and better and better, and it's all a way of capturing all that. It's making sure that applies to your infrastructure as well as your application. That all those little bits of improvement, all those marginal gains, all those little, you know, the regular, all the things you capture, and you're just making sure that's embedded so that you've always got that goodness in the future.
Exactly. Exactly.
So nice. Principle number 4: adopt infrastructure as code. And this one kind of segues quite nicely into principle number 5, which is adopt an immutable infrastructure approach. So this is kind of another facet or another principle that goes on top of that. But a lot of people can, you can adopt infrastructure as code, and you can have your infrastructure in a repository, but you can still use desired state rather than immutable. So I suppose we need to kind of explain a little bit about the difference between those things and why immutable is the way to go.
Yeah. So the idea behind immutable infrastructure is that instead of making live in place updates to things like machines, and continually doing that where there are any changes, is that let's say you've got there's a CVE security, um, there's an alert, and let's say Amazon produce a new virtual machine image. which patches that Linux image. And you need to now deploy that. So you're better off, in my view, and this is what a mutable infrastructure approach takes, is that you would actually make those changes to your image in a sort of out of band or offline manner. You can test that, and then what you do is you deploy those new virtual machines for the new images, and then migrate your workload over to those new images, and then effectively shut down your old images. So what a mutable infrastructure means is that you basically add you so rather than make changes in place, you add new machines or new application containers to the environment as new versions, and then you migrate workloads over, and then you get rid of the old versions.
And
So
and there are kind of a couple of important things in that. One of them is that if the infrastructure is immutable, then you know every single time that you've got a clean build. So that's one good thing, is that as you go through environments and all that sort of thing, from the ground up, you've got a clean build every time. And the other one is really that when we're talking about availability and not losing service, is that if you've got your new infrastructure ready to go, and it's a question of flipping over the workloads, then you have that kind of 100% availability, but you've also potentially got rollback as well, because your old infrastructure just can still exist, and your new infrastructure is in place, and so you can start to migrate workloads over. But if there's a problem, you can migrate them back. Whereas when you're doing a desired state kind of update, it's a lot harder to do that, because you're making changes on the working machines themselves rather than having separate ones.
Yeah, and that's the sort of the inverse. It's mutable infrastructure. So the tools like Chef and Puppet take a mutable infrastructure approach, where you will have a desired state for the machine config, and it will continually make sure that machine matches the desired state. But over time, you can get issues such as configuration drift. And so if you take the immutable infrastructure approach, then you can create a brand new image, new version of the image, which has got new patches applied to it, or whatever the configuration is. You can make sure that that's tested. You can store the image away in the cloud as a new image, and then deploy new nodes into your cluster. So we use Kubernetes. So deploy new nodes into the cluster with a new image, and then effectively get Kubernetes to migrate the workloads over to that new node. So at no point are we making in-place updates to the node.
Yeah.
Any changes to that node happen offline. New images are created, and those new images then deployed as new nodes. It's the same approach with application containers. So rather than let's say if you could, so making changes to that container while it's running, or in-place updates, and this is probably more natural with container application containers. What you do is you make a change to the code, you build a new container, you create a new that container, push it to your registry, and then deploy that new container into your environment.
Yeah, when you're doing containers, that's you kind of,
it's more natural, isn't it?
It's more natural, because that's the mindset of containerizing your applications from day one. Really.
Exactly.
It's just a bit of a leap to take that same mindset into containerizing your infrastructure, or making your infrastructure immutable in the way that
exactly. Yeah.
Before. I mean, I would say just to stick up for Chef and Puppet. If you're going from if you're going from a point where you've got people going click 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 on wizards, Chef and Puppet are a massive improvement on that. However, we just feel that we can do even better by immutable infrastructure.
And to be fair to the configuration management products like Chef and Puppet, desired state is still a good approach, and we use that. Well, we don't use Chef and Puppet. We use a desired state approach for not nodes, so not for virtual machine configuration, but for more the sort of overall infrastructure environment. So so for example, we don't just run an EKS or Kubernetes cluster in AWS with some EC2 nodes attached. There are all sorts of other resources in Amazon, in AWS that we need to provision for a working environment. So there are lots of, IAM users, roles, policies, all of the, there are certain services that we use that, KMS, Secrets Manager,
Yeah.
so all of these things are all there to support, all these resources are there to support the application, the cluster. So whilst we take an immutable infrastructure approach to nodes that are running containers, and
Yeah.
always
So when we are spinning up the machine, it's immutable. However, that where we're using a more of a service, then we're looking at desired state on that.
exactly. So the actual environment itself that runs that cluster, we use Terraform, and Terraform takes a desired state approach. So we have a desired state approach to the overall infrastructure environment, but the cluster, the workloads running on the cluster is more of an immutable infrastructure approach. So we have a bit of a blend, but but I think immutable infrastructure is really important particularly for nodes, particularly where you have security fixes that you need to apply. It just makes so much more sense on container orchestrated tools like Kubernetes to just deploy new nodes, attach them to the cluster, migrate your workloads over, which is really easy, and then just shut down your old nodes. That's got to be far better than trying to do in-place updates to those virtual machines. So that's effectively what we do. What we haven't talked about just yet is the strategies for migration, because then that becomes really important. And so there are various different approaches for migrating workloads, such as blue-green, or if you're Netflix, red-black, right? So if you're using Spinnaker, which came from Netflix, then it's red-black, but or
Yeah,
Canary.
and we've adopted a purple and white approach to that.
So, but yeah, it's there are sort of strategies that are becoming the norm for doing this type of migration. And as you mentioned earlier, that when you do migrate, if you then experience problems, while you still have the old versions deployed still, you can always roll back, which simply is a case of repointing traffic back to, or workloads back to the older, either the older containers or the older nodes. So, immutable infrastructure really does work hand in hand with strategies like blue-green.
Oh, fantastic! So, have we covered that one off?
I think so.
Principle number 5, immutable infrastructure. So, what we're going to do now is we're going to take a break now, and we are going to pick up in next week's episode. So we've done principles 1 to 5, which are, so recapping, everything is automated, and Git is the source of truth. We don't store sensitive data in Git. We adopt infrastructure as code, and we adopt immutable infrastructure. Those are principles 1 to 5. And so next week we are going to pick up with principles 6 to 10. So I'd like to thank everyone for listening to part 1 of this amazing 10 principles of DevOps, and we look forward to catching up with everyone in part 2, where we cover off 6 to 10. So thanks for listening, and we'll see you in the next episode.